We're here with Team 21931 Westside Gray from West Lafayette, Indiana. They're here to show us their Into the Deep FTC robot.
So our main strategy is to get things from the high and low basket and score the samples into that. And we can also reach a level 2 ascent and possibly a level 3 ascent. We also have an autonomous.
Our main plan for autonomous is to score a sample in the high basket and park, because that's all we have time for, because the autonomous period is only 30 seconds long. We also have teleop.
Our teleop, we can switch between robot and field-centric.
Do you guys think you could walk me through, for instance, your whole arm mechanism, how you guys pick up, how you move it, and how exactly you guys place?
So our arm is like 3 main parts. There's the elevator, which goes up and down, and there's the arm that rotates, and there's the claw with rollers that grabs the pieces. So we will put the elevator like a little bit up and then move the claw down to reach into the submersible and grab samples. After that, we will put the elevator all the way up and then put the samples into the high basket. And the rollers help because many of the other teams, they take like some time aligning the claw with the pieces, but the rollers just kind of funnel in the pieces into the claw so that we can get it easier.
Something I really love about your robot is just from the outside, it seems like it's really easy to work on. I see you guys have these cool panels, and even looking in, well, I wouldn't, it looks like the wiring is really easy to work on. There's a lot of space in a lot of these mechanisms. Could you talk about any decisions you made to try to
So our drivetrain has like 2 separate boxes on the sides that have our motors, which are stacked on top. And basically we have these doors that protect the inside, so that all of our wiring can be easily like changed or switched out. Yeah.
Cool. I don't think I've ever actually seen these like pivot gear holder thingy. Could you talk about how you make your slides, how you actuate your slides?
So our slides have these spools of just this like thread rope thing, and so if you see,
are those 3D printed or are they like bought off the shelf?
The spools I think are bought off the shelf, but our gearboxes and other things are all 3D printed. So when you raise these up, the tension from the spools will cause the spools to slowly unravel. But if you see, there's enough tension that if you let go, it'll come down by its own. So that way when the motor turns, it'll keep the tension so that it'll stay up. But if you turn the motor off or reverse the motor, it'll go back down.
That's really cool, thank you. Is there anything else you guys want to talk about?
So we have these door panels that, so there's a rule that you can only have possession of 1 sample or specimen at a time. And if it falls into our robot, then we wouldn't be able to get anything else during the game because like we would already have our 1 sample, and then if we tried to get more, we would get a penalty. So many other robots, if for example the sample drops from here, they could fall into their robot, and they can't really do anything about it because they're not like prepared to like push the sample off or anything. They can try like driving around to try and get it off, but that's going to take a lot of time. So we had these doors to kind of prevent that. Now there still is some space, but that's kind of unavoidable because that's where the claw needs to move.
And if it falls on this side, it will just naturally bounce off.
That's really cool. If you don't mind me asking, what like materials did you choose for all these doors and all the enclosures?
So all of these things that you see that are like tinted gray are all made of polycarbonate, which is like we cut it specially in a machine to like have it fit to our robot size, and it's just like specially made, I guess. And then these like that are like more saturated gray are 3D printed, and we have like 3 3D printing machines, so we can get a lot of things done that are 3D printed, and that can be so that our robot has more like unique components.
And then our arm is also made of carbon fiber, which we also cut, but you can pretty much find that. But I would say it's still kind of special because it's not something you can just buy at like Walmart or something.
Yeah, that's all really cool. Thank you guys. That was Team 21931 Westside Gray from West Lafayette, Indiana. I really wish you guys the best of luck in this upcoming tournament.